In this video, we're going to talk about how to factor a polynomial given a zero. So we use these words a lot, I know, in these lessons, so I just wanted to kind of summarize everything. So that's what this chart here is for. So a zero, remember, is a value of x that makes f of x equal to 0. So for example, 2 is a zero of this function because I plug it into this function, I'm going to get 0. A factor is what happens when we take that value r that's a 0 and then write it as a binomial. So we write x minus r, and that's a factor of this polynomial f of x. So for that 0, x equals 2, we could write the corresponding binomial, which is x minus 2. So a root is something that you can find by taking that function f of x, setting it equal to 0, and then solving for x using the zero product property. So remember, we can do that with the factored form of the equation. So for example, if we have this f of x and set it equal to 0, and then we factor this left side, we can set each of these factors equal to 0, and we can find the roots. So for example, one root that we'll find is that x equals 2, because if we set x minus 2 equal to 0 and solve for x, we get x equals 2. Remember, this also ties into those x-intercepts, because if a value r is a 0, it's going to have an x-intercept at that x value, right? So if we graph this function f of x for that x equals 2 that we said was a 0 and a root, it will also have an x-intercept at 2, 0. So for example, if we have this graph, we can identify the roots and factors, right? We've already talked about this. So you can see that it has those 3 x-intercepts, so we know it's a cubic function, and we can write the factors that correspond to those roots. So those roots would be like x equals -3, x equals -1, and x equals 2. The corresponding factors would be x like minus -3, which is going to be x plus 3, right? Because remember, we turn a minus negative into a plus. We'd have x minus -1, which is going to turn into x plus 1. And then we have x equals 2 corresponding to x minus 2. So we could actually write this function f of x as the product of its factors. We could say that this is equal to x plus 3 times x plus 1 times x minus 2. Okay, so that's how you can write the polynomial. So we can expand on these ideas and then factor a polynomial f of x if we're given just one of its zeros. So given that x equals r is a 0, we can write the corresponding binomial factor x minus r. Then we can use synthetic division to divide the original polynomial f of x by this factor. Remember, that'll give us a depressed polynomial that we can write, and then we can factor that depressed polynomial using the factoring methods that we talked about a few lessons ago. And then we can finally write f of x as a product of its factors, and remember to include the x minus r that we originally factored out. So let's see what that looks like. Let's try factoring f of x equals x cubed minus 4x squared minus 20x plus 48, given that x equals 6 is a 0. So you can see that this is a third degree polynomial, so we know it should have 3 zeros. But all they've done is told us one of the zeros. Well, this 0 at x equals 6, we know that corresponds to a factor of x minus 6. So I'm going to perform synthetic division here, and so let me make sure I don't have any skipped terms. Just going to add in that coefficient of 1, so I have 1, -4, -20, and 48. Okay, so let's use synthetic division here. I'm going to bring down 1. 1 times 6 is 6, -4 plus 6 is 2. 6 times 2 is 12, plus -20 is going to be -8. 6 times -8 is -48, and -48 and 48 are 0, which makes sense because we know that x minus 6 is a factor. Okay, so remember, what we can do is once we have these values in the last row, we can write the depressed polynomial. If this has a highest degree term of x cubed, the depressed polynomial will have a highest degree term of x squared. That x squared is going to have a coefficient of 1, but I don't need to write coefficients of 1, so I'm just going to leave that as x squared. And then my 2 is going to correspond to a 2x term. Minus 8 is going to be my constant term. Well, look at this now. We know how to factor this kind of trinomial, right? So this is a trinomial where a equals 1. So we just look at the value of c. C is -8, and remember that 2 is our value of b. So we need factors of -8 that are going to add to the value of b, right? So they're going to need to add to 2. So remember, since 8 is negative, we're going to have a positive factor and a negative factor. Since 2 is positive, I'm going to make all of the bigger factors positive. So let's now list out the factors of 8. Well, they're 1 and 8, right? And we have 2 and 4. Let's make all the bigger factors positive, smaller factors negative. So negative 1 plus 8 is going to be 7. Negative 2 plus 4 is 2, so that's the pair that works. So I can now factor this trinomial as x minus 2 times x plus 4. So what I do now is I take these factors that I found and combine them with that original factor that I, took out of that expression, and I write them all together. So I can say that f of x in factored form is x minus 6 times x minus 2 times x plus 4. Okay, and that is the fully factored form of this polynomial. And if you want, you can actually go ahead and multiply these together and see that it does in fact equal the original polynomial f of x. So now you can go ahead and pause the video and try doing this example on your own. So you can see here we have x equals 2, so that's going to correspond to x minus 2. So if we use synthetic division, we have 2, and then we have 1, 4, negative 3, and negative 18 as our coefficients. When we do synthetic division, we need to now write the depressed polynomial. Since this is a cubic polynomial, the depressed polynomial will be a highest term of quadratic. So 1x squared plus 6x plus 9. Notice that this is a perfect square trinomial, right? Because the first term is a perfect square and the last term is a perfect square. So in this case, a is going to equal x and b is going to equal 3. And if I check 2ab, that does give me 6x, which is my middle term. So I can rewrite this as x plus 3 squared. So I'm going to take that x plus 3 squared and put it with that first binomial I factored out. So I have x minus 2 times x plus 3 squared. So remember, if r is the zero of a polynomial, that means that x minus r is a factor of the polynomial. After dividing the polynomial by this factor, x minus r, using synthetic division, you can factor the depressed polynomial to fully factor the original polynomial.